block. Okay, plummer block assembly. All right. Okay, so in today's class we'll see plummer block assembly. Yeah. Yes. Okay. Yes. Can you see the screen? I've shared the plummer block assembly. Hello, can you see the screen?
No, sir.
No, not yet. Okay.
Yes, sir, it's seen.
Yeah, okay. Okay, I'll reload it. Okay. Yes. Yes, can you see it now? Can you see the screen? I've shared the
Yes, sir.
drawings. Yes? Okay, all right. Okay, so before going to the parts and the assembly, let us see what is this plummer block. Okay, so plummer block looks something like this, as shown in this diagram. Okay, plummer block looks like this. So there are about 8 parts in this plummer block. Okay, when you look from standing in front of it, okay, it looks like this, where you can see here they are shown right front sectional view. See, the right side of the front view is sectional view, but not the left side. Okay, right? Okay. Now this plummer block is meant for what? Now plummer block is meant as a shaft holder, just to tell it in very simple words. Okay, and which will support the shaft. Now say for example, one of the thing is in turbines, where the turbine will be situated in the basement. In general words, I'm just telling, and the shaft connecting from the turbine uh, should be connected to the generator. Okay, so it's a very long shaft with a huge diameter. So, but when the turbine is rotating, even the shaft is also going to rotate. Okay, and whenever you have a very long shaft, there's a tendency that it will either bend and also lead to wobbling. Okay, right? So to avoid such bends and to avoid such wobbling, okay, we need to give some support. We need to give some support to the to this shaft. Okay, but this shaft we cannot just hold it, because when it is in working condition it will be rotating. Now how do you hold it? It is already rotating. It is like this, uh, like somebody is pedaling a cycle. Okay, you are trying to catch hold of that wheel. Can you just catch hold of that wheel just as it is? Hello?
No, sir, no.
Right? It'll harm your hands, right? When the wheel is rotating and when you try to hold the tire, right? Because of the force, it is going to harm your hand. Okay? Right? Right? But still, we have to give some support. It is some kind of situation like that. Okay, it is not only in the turbine sections, in even in the ships. Okay, then even in many other places. Okay, where we have to connect one element to another, I mean one component to another component through shafts. Okay, and which are located far away, then yes, we make use of the shafts to connect, but over that length, okay, there should be some kind of provision to hold the shaft so that they don't bend, as also not to wobble also. If they bend, then they're going to lead to wobbling, right? But still the shaft should rotate and transmit power. Okay, right? So in that case, what do? We make use of a bearing. okay, which will hold the shaft. So when you put a bearing across the shaft surrounding that, okay, the shaft can rotate freely inside a bearing, uh, just like a wheel. So you can see, so say for example, if this will be the shaft upon which you will have the hub for a cycle. I'm telling, it's almost the same assembly even in two-wheelers also. And this in this hub, at one end you will have the bearing over here, and there will be another bearing over here, right? And above this hub will be the wheel assembly, right? Above this will be the wheel assembly, okay? The wheel, then the spokes, or even if it's alloy wheel, then the tubes and tires and so on, right? Okay, so just similar to that is this place where we have the bearing, not exactly the bearing, we have the upper and lower half curves that we are having over here, which will give the similar thing, motion like that of a bearing. Okay, and this portion of the body that you can see, part number one, will hold all the other elements in place, right? So what you can see over here in this shaded portion is the shaft. Okay, is the shaft that is going to pass through this plummer block. Okay, right, and this plummer block will be fixed to the ground, okay, so that this plummer block does not move away during the operation, right? Okay, and at suitable places after particular distance, this plummer block will be installed, and the shaft will be aligned from one end to another end, and this part number 2, then 6, 5, 6, 7, and all those things will be assembled so that they hold the shaft firmly in one place and allow it only for rotational motion, right? Okay. uh, yes, so this is about plummer block. Okay, and just a second. Okay, I'll show you how a plumber block looks in three-dimensional also. See, it looks like this. We have the body, then the cap, and this is the upper half and the lower half, and then with bolt and nuts. And in this place, there's a hollow place, okay, where the shaft will be inserted, right here. Yes, this green color portion is the shaft, okay, which can pass from one end to the other end. So this plumber block is going to be the one that is going to provide the support for the shaft so that they don't bend and wobble. Is that clear? So this is how the entire thing looks like. Is that clear? Any doubts till here? Any doubts? Yeah. So we have to draw the parts of this plumber block and assemble them, right? Just like screw jack, that entire procedure we have to do it for this plumber block assembly. Okay. All right. Okay. Shall we proceed? Okay. All right. So let's go and see the parts that they are given. Okay. Yes, so here we have the diagram that will be given. So, but before that, let us read the question. Okay, so one is, so views of the parts of a plumber block are shown in the figure or and so on in figure. Draw it to 1:1 scale with the following views of the bearing. Okay. Now, first one, what are they asking? Front view showing right half in section. That is like this. Only the right side portion of the front view should be sectional view, not the left hand side. Then top view with right half in section and right view. Okay, right? So they may ask like this. Okay, and this we are done. What is front view with the right half in section? We have already done it uh, in screw jack assembly. Okay, right? So only the right half of the portion in the front view will be in sectional view. Okay, the left half will be only a front view. Okay, and they can ask the same question, but they may change this. They may ask half sectional front view, top view, and left side view or right side view. Half sectional front view means what? The one that we did in section of solids, completely sectional front view. Okay, right? I'll once when we come up in to assembly, I'll show both of them once again, right? Okay, so please read the question always and do it according to the views that is that they have asked. Okay, it can be right half sectional front view or only half sectional front view, so please do it accordingly, right? Okay, now we have to create all these parts first. Okay, we have to create all these parts first, all the 8 parts. Okay, right? Okay, and one more hint I'll give you now only. See, now look here, part number 5. Okay, bolt. Part number 6 is a nut, lock nut. Part number 7 is a nut. Part number 6 is lock nut. Part number 7 is just a nut. So this 3 parts is again placed onto the other side also. Okay, right? So it will be the same dimensions, same shape only. So we need not have to redraw this once again. Redraw this once again. Okay, we can only we can do it only once. Okay, right? Okay, so like that also we should see. So we have to see which is the easiest way to complete the drawing, but with it should be with all the specifications, dimensions, everything as it is. Okay, not skipping anything. Okay, right. Okay, so now let us read the drawing. So yes, so let me go to the bill of materials first. Okay, yes, so part number 1, what is there is the body, which is made up of cast iron. Part number 2 is the cap. Okay, that is the this particular part, the upper portion over here. Where is part number 3? It is here. Part number 3 is the bearing bottom half. Okay, like here it is 2 half circles, right? This particular portion I'm talking about. This is bearing upper half. This is bearing bottom half. Okay. Then bolt M10, nut M10, lock nut M10, and shaft. Okay, so part number 5, 6, 7, 2 times we need. So that is why just look at this last column. How many parts are required for to make one complete assembly? Body we need 1, cap is 1 part that is required, bearing bottom half and upper half is 1, but bolts we need 2 bolts, one on right side, one on left side. And similarly for nut and lock nut also we need two lock nuts and 2 nuts. Okay, and 1 shaft, right? Okay, so the first thing is the body. We'll go to the body, we'll read what is the dimensions, how it looks like. Okay, so yes, so body looks like this. Okay, so they've given the front view and top view, right? They're given the front view and top view. Now if you look at the front view, it is a front view with right half in section. See, only the right half portion of it is in sectional view. Okay, and yes, so now what is it? The length is, overall length is 168 mm. Okay, the overall height of this body is 55 mm. Okay, so we got the length and the height. Now whether it's circular or rectangular we should see. So now go to the top view. The width of this is 36 mm. So it is a rectangle, 168, okay, with a height of 55 with a width of 36 mm. So we have to create a rectangle first initially in the 2D drawing. Okay, and then comes the other things and all. Right, so there are many ways to get this shape. Okay, we'll show you one of the easiest ways. Okay, and inside this we have the other counter boring hole and other things. With here at the center we have in the front view, if you look at it, okay, in the front view if you look at it, there's a semicircular portion, not exactly semicircular. I'll show you that important thing. So the region over here is that if you look at this, see this curve, okay, it's not a semicircle, it is little bit more than a semicircle. Why? Because see the center is over here. The center for this semicircle is over here, right? Okay, but this arc starts little bit above than that, okay, by 3 mm, by 3 mm. Okay, so actually the semicircle is from here, from this particular point. Here, but this is little bit above than that, another 3 mm. Okay, then after that is this straight line. Right, which is for 12 mm. Okay, then after this, here at the center, we have a hole for 6 mm diameter for a depth of 6 mm, which has got a V tapering. Okay, right. And now coming to the places where the bolts and all those things are going to come in place. So there's a small, there is no material for about 2 mm. It is here. So just read this dimension. Right, for 2 mm. So this gap is for 2 mm. Okay, then after that, above this uh, there's a place for the bolt head to come into place, which is going to be for a height of 7 mm. And then is the bolt region, and here the base height is 14 mm and has got a slanted surface, okay, which is for inclined at not the angle, it is 4 mm away from the other corner, right? So such details has been given. Okay, right? Now we'll see one by one how to draw this assembly. Okay. We'll see how to draw this assembly. I'll just keep it here. I'll just zoom in only part number 1. Okay. All right. So let us go to the how to draw this part. Okay, see the other way is that initially once when you start to draw the part itself, you can give save, you can click on save, okay, and give all the details of the part, that is the body, which is the project title, which is called as plumber block assembly, document number and all those things, and click on save. You can save it in a plumber block folder, okay. And then what is the advantage of this is that after you do any progress in this, you can just click on save or press Ctrl S, so that the whatever the progress that you have made is going to be saved intermediately, right? We are keeping on saving, we are keeping it updated from time to time, so that even if you lose any data, there will not be any problem, right? Because we have already saved it. Okay, right. So now let us see this, the construction. Okay, I'll also share this Plummer block uh, drawings to you in the WhatsApp group, so that even uh, you can see it clearly, so that we do not have to uh, keep on flipping between the drawing and the part creation. Okay, so I'm sending it now. So please keep this, and you can refer this as I'm teaching it. Yeah, I've sent it in the WhatsApp group. So please open that photo and concentrate on the part number 1. Yeah, right. Okay, so part number one, what is it? Basically, we have to first draw the base, which is for a length of 168 mm length. Height is 55, width is 36. Okay, but we'll see how to construct it. Okay, now here, so file name will give us the name of the part, which is body. Choose sketch, choose the front view plane. Okay, now look at that. We'll draw one line horizontally, which should be at a distance of 3 mm. Okay, it should be at a distance of 3 mm, which they have given it here, 3 mm from the center of this semicircle. Okay, above that center. Okay, make it 3 mm. Okay, then go to circle. What is the diameter or radius of this circle? Have they given it here? This particular one? Have they given this? This dimension is not given, right? In the front view, it is not there. Okay, so if it is not in the front view, please look at it in the other view. Yes, please look at it in the other view. Okay. This is for the other one, right? Okay, so just look at this. They are not mentioned it here as diameter. Okay, and they have given only the distance between these two arcs. Okay, of the semicircle is 38 mm. Okay, so the radius is going to be half of this. Okay, so diameter 38. Okay, and look at this. When you place the circle, it is not going to be the center of the circle is not going to lie onto the line that we have drawn. Instead of that, it will be 3 mm below. That is this, where these two planes intersect. Yes. So we'll draw this portion. We'll draw this particular portion. Okay, now see, we'll give the approximate We'll try to get the shape with approximate dimensions as of now. Go to mirror and uh, mirror it onto the other side also. Now trim the unwanted edges. Right? Now it looks almost same as that as what was shown in the part drawing. Okay, but it is not to the exact dimensions. Okay. Now go to smart dimension, give the dimension. So this should be 14. Okay. This one should be 12, which they have indicated. And this distance should be 168 by 2. Okay, which they have given it here. The overall distance of this is 168 mm from end to end. This is 84 mm. And this radius is 19 mm for the semicircle. From here to here, it is 44. Okay, so look here. So look at this. This 38 mm is for the semicircle that they have shown over here. This 44 mm dimension is from this particular line to this particular line over here. And now, yes, so this, what about this distance, this particular distance? I'll just show you here. What is the distance from here to here? How much it is? It is not given here. The height of the plumber block is given, which is 55 mm. Right? The height of the plumber block is given as 55 mm. But what is this distance? We need to know at least from here to here or from this end to this particular end over here. Both of them are not been given. Okay, right? So if it is not over here, go to the top view. Now just look at this. Okay, so I'll just project it. So how does these two ends look like in the top view? It looks like an arc. Okay, curved manner. Now what is the dimension of that? It is 43. It is 43, which is indicated over here from the center. Okay, or from the middle of the plumber block. Okay, so thereby over here we are going to have a curved surface with a radius of 43. So distance between this from here to this center is going to be 43 mm, right? So that is what we are going to take it over here. So from the center to the one end of the plumber block will give it as 43 mm. Yes, you can see here. Okay, right. And this total height should be 55. Okay. And there's a slanted surface over here at the base by a distance of 4 mm. And now trim this unwanted edges. Mirror it onto the other side also. Now return back. Okay. Now what you do is that, yes, the front view same shape with same dimensions has been created. Now we have to extend it. Give protrusion for a distance of 36. So now we will give symmetric extent. So we have drawn this exactly at the center over here. Now we'll give symmetric extent so that the plumber block is going to lie being protruded equally on both the sides. Okay. So we'll go to protrusion, select the sketch, accept it. Okay. Give symmetric extent over here in this particular place. Okay, and give the overall distance, which is 36. So now you can see that this blue color line is the what we have drawn. The solid that we are able to see, which has been distributed on both the sides, is overall it is for 36 mm. Okay. Now we'll go to the bottom portion. We'll rotate the solid. Okay, because why we are going to rotate? We have to give the other features like this. So there's a gap. There's no material for about 2 mm in this region. Okay, but what is the shape of this? The height is 2 mm. What is the shape of it? Whether it's circular, rectangular, square, what is it? Okay, so one thing is that from the axis there is material up to 8 mm on one end. From the other end of the plumber block there is material for 8 mm, but in between these two there is no material. And then the other thing is that now once we look into it, what is the shape of it? Distance I got, what is the shape of it? I'll just project it and I'll show you. See, this portion is only hollow at the bottom. So when you look from top view, it should be in dotted line, right? So it is, now you can see this dotted rectangle, which indicates that. So it's a rectangle over here. Okay, it's a rectangle over here. Okay, right, exactly placed at the center, and you can see onto the other side for this rectangle over here also, there's a distance of 8 mm from uh, the edges of the plumber block. Okay, 8 mm here, this particular dimension, right? 8 mm inside on all the 4 sides of the rectangle. So we'll go to the bottom of the solid that we have created. We'll draw one rectangle. We'll offset it inside by 8 mm because equally it is 8 mm on, inside on all the 4 sides. Because they have not given the dimensions of this rectangle. What is the length and the width? They have not given. It is at a distance of 8 mm from all the 4 sides. That is all they have given. Okay, so if we have to draw the rectangle, then we have to find out what is the length and the width by subtracting. Okay, right? So the other way is that from the edges we draw parallel lines inside by 8 mm from all the 4 sides. Okay, now we'll go to cutout because there is no material over here. If you see it here clearly, see there's hatching above but not at the bottom surface for this 2 mm. That means there is no material. Okay, so for 2 mm depth of cut, we'll give cutout. Okay, for 2 mm inside. Okay. Now once we complete this, select that inner surface so that we can give the other one, the hollow space that we have to create for the bolt head that has to be fitted over here, right, which is for a square of 20 mm. Okay, so it's a square headed bolt. We had studied the square headed nut and bolt. Okay, so here the head of the bolt is 20 mm. Okay, so we'll draw one square for 20 mm dimensions, but we should see where is it located at. Okay, where is it located? Okay, where should this square of 20 mm be located? Yes, I'll draw here. The square is going to come up over here. You can see in the top view there's another dotted line that has been written over here, right? Vertical lines, dotted lines. So for this the center of this is what? From center to center, it is for a distance of 62 mm. Yeah, 62 mm from both the centers of the square that has to be drawn. Right, so half of this is 31, so the center of this square should be the center of this square should be at a distance of 31 mm from the middle of the plumber block. That's all is the detail that we have. So we'll draw one square of 20 by 20. Initially we'll draw one square. Just draw the square. From now, from the center of this square to the middle of the plumber block, get a dimension for a distance of 31 mm. Yeah. From the center of this square, that means midpoint of this horizontal line, to the center of the plumber block, take the dimension as, make it as 31 mm. And now give cutout for what distance? It is a hollow place for 7 mm. Okay, so we'll give cutout for 7 mm. Now we have to make a hole above the square, okay, and whose dimension is, I'll just show you here. See, now we have to make this hole, okay, right? The dimension of this hole is given in top here, a circular portion indicating two holes diameter of 10.5. Okay. Yes, now we'll go to hole options. It's a simple hole. Diameter is 10.5. Okay. Extend to the throughout the surface or up to next. So from the square that we have drawn, from that the center. Yeah. Now after doing this, please observe carefully now. Go to smart dimensions. From the center of the circle to the middle of the plumber block, it should be at a distance of 31. Yes. Okay. Right. Okay. Now all these things, features has been done on one side of the plumber block. Okay. Go to sketch. We'll take this flat surface. Okay. Now we are going to do this particular region, the hollow surface, which is going to be, just look at its shape. It is going to be something like an oval shape, right? Not a circle, not a oval also. So to do it, one of the method is we'll draw a rectangle, put it at to and in the center of its width, give the dimensions that so just do carefully which are the ones that we are trimming to get that shape. Now go for cutout, completely remove that material in that particular place. Now all the features has been done on one side of the plumber block. Onto the other side also we have the same thing represented here in dotted line. because it is only a front view portion, okay, not a sectional view, but still the same features exist. So instead of doing it once again, we'll only copy these features. So we have copy option over here, mirroring. Okay, before that, okay, now I told you that this distance between the two ends of this plumber block at the top surface is has a curved surface of a radius 43. Okay, we have to do that. Now we'll go to top view. We'll draw one circle for a radius of 48 from the center of the plumber block. Okay, and now we'll go to include and select the required edges, that is the ends and this particular one. Okay, right, I'll show you why we are doing this, because before doing this and something went wrong, just a second. See, look here, it is now like a rectangular block over here on the top surface, which we have to make it as a curved surface, right? Okay, so nearby we will go to the top view. Sorry, just a second. Yeah. Yes, we'll go to the top view. We'll draw one circle for 43 mm radius. Then choose include, select the edges of the plumber block, and now we'll trim the unwanted lines or arcs. Just look at it carefully. Yes, and the next one. Yes, so whatever is this retained portion with area within this blue lines is the one that we have to remove. Okay, so now we'll go to cutout. And we will cut this. Now see whether it will ask you whether we have to move it downward for cutout or in the upward direction. Material is in the downward direction, we'll move there. So if I do complete cutout, the other parts will also get damaged. The other regions, we have to give it for a particular length only, or up to next surface. Right? And then there's a radius of 6 mm over here, or a fillet. So we'll go to fillet, radius 6 mm. This particular edge will be turned to 6 mm fillet. Yes. Now what we are going to do is we have to draw this hole that has been made at the center for a diameter 6 mm, depth of 6 mm. Now already I told you we cannot select any curved region. We cannot select any curved region to do any kind of operations, whether to drill a hole or select that curved surface is not possible. Okay. Now how do we do that? Because the hole is now drilled on a curved surface. Now how do we select it? We'll see. So we'll go to hole, option 6 mm diameter. Depth of the hole will vary, which will be 25 mm. Okay, why 25 mm? Okay, why is it 25 mm? I'll explain it here. Okay. Now what is the radius of this semicircle? The radius of the semicircle is, if I'm correct, it should be 19 that we have already drawn, right? That means the height of this semicircle from this arc to the center is 19 mm. So this length is 19 mm plus 6 mm. So 19 plus 6, 25. Why are we taking this? Because here we have the plane. Okay, the reference planes is here. So we can draw anything on a reference plane. So from the reference plane, if I measure, it is 19 mm plus 6 mm, 25 mm. That is why the whole depth we are giving as 25 mm. So select the plane, horizontal plane over here. Now from the center, place the hole, okay, position it and click on finish. Okay, now we'll go to mirror, and all these uh, hole, bolt, head regions where it is going to come up, all those things will mirror it onto the other side of the plumber block. So we'll select all those features. We'll just look carefully, mirror. We'll select all these operations that we have done, which we can see here onto the left side. Okay. So one, use the control key to select them. Okay. See, cut out one, two, hole one, and all those things. Click on smart over here. Okay. This is the smart icon button over here. And just click on the reference plane. All these features will be copied onto the other side also. So the plumber block is ready now. So now click on save, right, and save this part. Okay. See here, first a depth of 2 mm, then the bolt head another depth of 7 mm. Okay, and then the bolt length starts for a diameter of 20 mm. Okay. Okay, so we'll go to the next part. Okay, now the next part is what excuse me. The next part is the cap. Okay, which is part number 2, which is located over here. It's shown over here. So here, okay, so again we have a semicircular portion in the front view, right, having a radius of 19 mm, and then there's another top surface, again a curved region having a radius of 36. The height of this over here is for 10 mm. Now this slab is placed at a distance of, read this dimension carefully, first thing is that from the edges of this cap, it is located at a height of 12 mm, but the center of this arc is located not exactly here, but it is 6 mm below, it is somewhere over here. So 12 plus 6, okay, right? And again here at the center we have a different kind of hole, okay, which is a countersink hole. Okay, we'll see that, which is having a depth of 10 mm, then upper diameter, larger diameter 6 mm, smaller diameter at the other end is 3 mm. Okay, and similarly, okay, there is other features which you can see in the top view. Distance between the two holes is 62 mm. Then radius of this curved feature is 12 mm. Okay, and this slab that I told you is not exactly a rectangle, it is curved with a radius of 43. Okay, now we will see how to draw this portion. Okay, go to sketch, select the front view plane. Now draw a line, horizontal line parallel to the horizontal plane for 6 mm distance. Okay, now go to circle, draw a circle for radius of 19 mm was given from the planes coinciding, another circle for a radius of 36 mm with the same center. Okay. Now draw the outer surfaces approximately. And now trim the unwanted edges. See, now we got very easily the shape. Okay, we have got the shape, but not to the exact dimensions. We'll do that now. Okay. Fix these two radiuses, 19 and 36. Give the dimension. Now the slab height is for 10 mm. Fix that also. If you do it the other way, the entire drawing will get distorted. Okay, so that problem also you will face. So we have to go in one sequential manner so that the shape doesn't get affected. Between these two, it is for a distance of 44 mm, and the distance between the center to one end of the plumber block is 43. Right, go to extend, symmetric extend for a width of 36 mm, right? Now take the flat surface of the block. We have to give the hollow portion, the curved region. Okay. So we'll do the same thing that we did it for the body of the plumber block to give that curved region. And now we'll try to do the other one, which is to make the hole at the center. Hole of 10.5 mm diameter, and it should be placed at a distance of 31 mm from the center of the plumber block. Now just look here. See here, it is just a straight line where this curved surface and this flat surface meets. But actually, if you look at the drawing, in the top view, it is not a straight line. You have another arc bend of radius 12 mm. So we will draw a circle concentric to the circle that we have already made for a radius of 12 mm. Use the include tool to select the edge and trim the unwanted lines or edges and cut out only in the blue color area that we have. right? Okay, right? So I'll tell you why we did this circle of radius 12 mm. Okay, now the next thing that we're going to do is this hole has to be made, which is having a diameter of 6 mm, which is actually the oil hole. Okay, it is used to pour oil into this so that it reaches the bearing and the shaft, which will provide lubrication. Okay, it will act as lubricants. Okay, where one end it is the hole is diameter 6 mm, the other end it is 3 mm. We'll see how to do this. So we have a curved surface now, okay, but we cannot do anything on a curved surface. So we have to have a flat surface first. So for that, the next tool is going to be parallel plane. So we have plane options. In that we can create additional planes to the already existing one. Now we can play this, we can have additional planes parallel to the existing one, inclined to the existing one, or perpendicular to the existing plane, right? Like this we can have it, many options are there. So in this case, what we need, now all we need from this particular region where we have a plane, here on the top surface we have the curved region, we need a plane over here. So we'll create a plane exactly at this particular height. So thereby I can select this plane and make the hole. So at what distance should this plane be offset? It is it is for a total distance of 36 mm. Okay, so we will offset a plane for 36 mm. Okay, so we'll go to plane, parallel plane. Okay, select that, select the horizontal plane. Okay, move it by a distance of 36 mm. Here you can enter the distance 36, or you can select that curved surface. So now you can see two horizontal planes lying, one below, one above. The one above is the one that we have created. Now I'll go to hole options. Okay, type of the hole, counter bore. Okay, now give the details that it is going to ask for. Diameter, 3 mm, counter bore diameter 6 mm, counter bore depth. Okay, so what is the depth of this counter bore? It is for 10 mm. Okay, select the plane, place it at the center and click on finish. Now copy the other features, the cutout, hole and all that we made to the other side of the cap. Okay, now you can see this curved region. Why we have created here a small region is so that above this place we are going to have the hexagon nut. Okay, so it has to be suitably placed. There should be some provision so that the nut can rotate and there is place for it. Otherwise, if you don't create this cutout, the nut cannot be placed over here. Okay, yes, so this is how we create the cap. Okay, all right. Okay, now let's go to the next part. Part number 3. What is it? So, part number 3 is the bearing bottom half. Bearing bottom half, bearing top half. Okay, we'll go to part number 4 first because between these two there's only a small change. Okay, so not much. Part number 4. Yes. Okay, we have part number 4 and 3 over here. Okay. Yes. So can you name which are the views that is given? So this is part number 4. This is part number 3. Yes. Yes. Can you name the views? Views, please. Identify the views. Okay, what they're given here is front right half section and the side view. Okay, so in the front view, if you look at it, it looks like a step. Okay, so here you see that there is uh, no hatchings. Okay, and one half of there is hatching, and when you look at the side view, it's a curved region, a semicircular arc type. Okay, right. So where the dimensions of that arc is given in the side view 25, then you have a dotted line, two dotted lines having a radius of 30, sorry, diameter of 35, another diameter 38, and then finally 50. And here the length of this is going to be 50. The distance between these steps is 36, 22, and 4 mm diameter. Okay, right? So if I just project it, see, this is going to be for this particular one, and this is going to be for this particular dotted line. Okay, right? Where this is going to be at a distance of uh, 20, sorry, 35 mm from the center. This horizontal line is going to be 38 mm from the center, and this is going to be for a distance of 25 mm from the center, an arc that has to be drawn. Okay, right. We'll see that how to do this particular thing. uh, Bearing top half. Yes, look at the video carefully. We'll draw one line or 50 mm, place it exactly at the center. We'll draw those steps, give the dimensions. So what we have given here is 19 mm is the radius. Okay, 17.5 the other radius. Right? Yes. Okay. Now we'll go to revolve protrusion. Okay, to create that curved or region, curved surface. Select the sketch, accept it, select the axis of rotation, go for 180 degrees, or you can give symmetric extent. Sorry, symmetric angle 180. Here you get the semicircular curved surface, half portion. Okay. Now we'll go to the top view. You have to draw a hole. We have to make a hole having a diameter 4 mm and extend it so that there's a complete hole made onto this bearing top half. Okay. And save the part. Okay. Now when we come to the bearing bottom half and top half, what is the difference? The difference is that on the top half there is a hole for 4 mm, but in the top half it is the same dimensions, same shape, but only with one additional feature. What is that additional feature? There's a protrusion for a depth of 5 mm having a diameter of 6 mm. So a cylinder is there having a length of 5 mm and the diameter of the cylinder is 6 mm. Only this is the addition. So you can see that difference over here in the side view shown in dotted line, because when you look from the left hand side of the front view, okay, this portion will be hidden because here we have a solid surface. Okay, so that is why here in the side view it is shown as dotted line. Okay, now we'll see that bearing bottom half. So you don't need to create the drawing once again. You can only copy the file, okay, and make only the required changes. How to do that? Okay, so this same file is there. Go to sketch. From here, draw it for a distance of 5 mm. Draw a line. Now go to plane. Okay, go to plane which is going to be perpendicular plane. Okay, perpendicular to this line we have to draw. That is why we have drawn that line 5 mm. Then we'll go to plane. Okay, coincident plane by axis. Okay, that is plane normal to curve. Plane normal to curve. The last but one option. Select the line and the end of the line. So a small plane will be created. Now with keeping this, select the smaller plane. Okay, draw a diameter of 6 mm. And protrude it. Okay, do the protrusion. And that's it. This is the only difference. Okay, the only difference between the bearing bottom half and the top half. Okay. Right. So next, we'll go to next part. Okay, which is part number 5, bolt M10. Bolt M10 is here, part number 5. Okay, so it's a square 100 bolt. The square size is 18 mm, length of the bolt is 75 mm, okay, and thread length is for 26 mm, diameter of the bolt M10, okay, right, bolt head thickness is 6.5 mm, okay, right, okay, so we'll see that how to do it. Uh, yes, okay. Just a second. Okay, yeah, so we'll first draw the square of we'll make it like a rhombus shape, okay. The reason why we have to make it like this, which you'll see at the end of this drawing. Now place this exactly at the center, okay. Hold it, place it exactly at the coincide planes where they coincide. Return back, view the protrusion for bolt head thickness, this is 6.5. From here, go to the top, the flat surface, go to circle by 3 points, select 3 edges of the square. Now go to protrusion, or you can go to circle, put it at the center, diameter of 10 mm. It's better that you go by the second way, not by the first way, it is not the correct one. Yes, the height of this cylinder is 75 mm. Yes, now go to the other side of the bolt head, choose circle or circle by 3 points, select any 3 edges of the circle, sorry, of the square, okay. Now then after that, very important, return back, okay. Now go to sketch, select the front view plane, see, so that you can see 3 edges of the bolt head, 1, 2 and 3, right. So to get this view only, initially we place the square, okay, in a rhombus shape. If you put it the other way, it's very difficult, we cannot do it. Draw an inclined line, okay, from the circumference of the circle, and make it for an angle of 30 degrees. Draw one axis line at the center. Now go for revolved cutout. Revolved cutout. Select that 30-degree line. Accept it. Then select the axis line that we have drawn at the center. This particular line. Now give the cutout for complete 360 degrees. So now look here. Now to get this curved surface only, we have to do this construction. Go for thread, hole. Give a chamfer at the ends of the bolt. Yeah, and then go for hole, threaded hole at the ends. Okay, only for a distance of 26 mm for M10. Yeah, click on finish. Yeah. Save this drawing. So bolt has been done. Now the next thing is part number 6, 7, 6 and 7, which is the nut and lock nut. Only a small difference if you look at this. Both of them are having the same hexagonal shape and size. Only the thickness is the difference. One is 8 mm, the other one is 5 mm. So create any one of them. Okay, save that file. You can copy that file and make the required changes. That is only the thickness. Okay, now we'll see how to make a nut. Okay, in 3D mode. Okay. So we'll go to part, sketch. We'll take the horizontal plane. First we'll draw one hexagon. M10. So the edges of the hexagon will be for 10 mm. So ensure that the hexagon is drawn in such a way, okay, in the same manner, only then it's going to be easier. Now go for protrusion on both the sides, totally for 8 mm. Okay. Now onto this flat surface. Yeah. Create a circle by 3 points. Go to the other plane, perpendicular plane. Draw a line from the circumference of the circle to edge of the hexagon for 30 degrees. Very similar to what we have done with the bolt head. Same operation. Draw one center line, come out, go to revolved cutout, select the inclined line and the axis of rotation and give cutout. Mirror this features onto the other side of the nut also. And now go to hole, threaded hole, M10. Okay, diameter is 10 mm, M10. Click on OK. Select the flat end of the nut. Now you can see that curved features that has been present exactly on all the 6 sides of the hexagon. And now we are going to do the threaded hole. Okay. Now this is how we prepare a nut, okay, but you can save this file, okay. Once we do this particular drawing, okay, save this drawing, okay, in the sketch we can go and edit it, okay. For the other one, I mean create a copy of the same file and then make the required changes. The only changes the thickness, okay. The procedure is same to create the other nut also. Okay, right. All right. So we are made with this, and then we'll go to the shaft, which is nothing but creating a cylinder. Okay. So the dimensions for this. Okay, it's a cylinder. Length is not been given, so we can take. I mean, for the shaft for any length, but let it be more than the width of the plumber block. So you can take 50 mm. Diameter of this shaft is 25 mm. Okay, which is indicated over here. Right. So now we'll see that it's a very simple part that can be made. Shaft, sketch, front view plane, go to circle, center, diameter 25 from the center. Okay, return back, go to protrusion, extend on both the sides for a length of 50 or 60 mm. Okay, give it for 80 mm also, not an issue. Let it not be for 50 mm, please let it be for, yeah, let it be for 80 or 90 mm. Okay, there's a reason why we have to do it for more than 60 mm. Okay, I'll tell that in the assembly. Okay, so yes, save this part. So now we have completed with all the parts that is to be created for a plumber block. Okay. Okay, I think so there was some audio problem. If you wouldn't have heard it, yeah, I don't know whether, did you hear what I told just now regarding the uh, nut creation and making the nut and the shaft? Could you hear it? Hello? Hello?
Yes, sir.
Okay, all right. All right, so we'll stop here for today. Okay, yeah, answer your attendance. And Madhu, yes.
Yes, sir. Yes, sir.
Then Mane Paniraj, absent, not there. Motion is also not there. Naman Shivananda,
Present, sir.
okay. Shrikant,
Present, sir.
okay. Then Pawan Kalyan, okay, he's left the college, right? Okay. Partha Sarthi,
Present, sir.
okay. Rahul Rathod,
Present, sir.
Rajat M. Patel, Reni
Present, sir.
Sibbi,
Sir,
okay. What
Rajat present.
happened? Reni Sibbi, what about this Reni Sibbi? Any idea? Rohan,
No, sir. Should I tell him to contact you or
yeah,
something?
yeah, please tell these both people, Reni Sibbi and Rohan Unikrishnan, to contact me. Okay.
Sure, sir.
Okay. Shreyas, yes. Shreyas, yes, is also absent. Not there. Okay. Samarth Nadik.
Present, sir.
Okay. Sayam Govardhan. Sayam Govardhan.
Present, sir.
Okay. Then Prayantan Banerjee is not there. Okay. Shashank KS.
Yes, sir. Present, sir.
Shashank MV.
Present, sir.
Okay. Shivkumar Patel. Not there. Sri Harsha Prasad.
Sir, present, sir.
What, Shriyasha Prasad? Last 4 classes you were absent.
Sir, I was not network problem, sir. Even I was not there at home. I was
Where do you
outside, sir.
stay? Where are you?
Sir, Kasaragod, sir.
Kasargod. Okay.
Yes, sir.
Some days network problem, some days what? During class hours, why are you going outside, ma?
No, sir, I was not there at home, sir.
No, why? Reason? Not there at home means?
Sir, I went with my family, sir. I went with my
Oh,
family.
okay. So take care. Try to be regular. Very important portions we are doing. Assembly drawing is not that easy. Yes.
Okay, sir.
Shubhankit Singh is also absent. He is also not there. Okay. Right. Okay. So thank you. Uh, please practice these drawings. Okay. And already I've uploaded the details in the Google Classroom. So log in over there, do the drawings and upload it. And also, as I told you in the previous class, as well as posted in the class group, okay, your first internals of CAMD will be on November 2nd. Okay, right? Portions, as I've already informed, is part A and part B. That is sectional drawing, sectional views, sorry, section of solids, orthographic projections, then threads and threads, okay, nuts and bolts, then joints, that is knuckle joint and quarter joint. All those portions, whatever we have done, all that is there. Okay, right? Okay, so we'll stop here for today. Thank you.
Thank you.